Okay, so just running, guys, we're going to run through parallel circuits today. You want to make sure you know that the total resistance is always going to be less than that of the smallest resistor that you have, always. There's an example, 2 resistors in parallel, each with 4 ohms. Okay, it's going to be less than that. It's going to be less than the 4 ohm guy. The equation we're going to use is this dude here. So for an example, I'm going to just roll an example off on how to use this equation. Now, what I suggest for you guys to do, all right, is open up a calculator, like open up a tab and type in calculator and have that ready for you. So you can practice this and it just goes, it's a lot easier. Because you try and use your phone calculator, I'm telling you, it's going to suck. It's not going to be easy. It's going to like screw you up. Okay, so make sure you guys all have that opened up. Now, all right, so we're doing 1 over, to find the total resistance, you need to do 1 over R1 plus what? All right, so here we go. Guys, someone's got their mic unmuted. All right, so parallel circuit, walk around, right? So when finding the total resistance, what you're going to do is you're going to add all the 1 divided by R's in your calculator, hit equals, and you're going to get a decimal. That's not your final answer. You're going to do 1 divided by that decimal.
So are we on circuit 1 right now for the Google Forms thing?
Well, we will get to that. I just want to go through a couple different things before we get into that. So to find total resistance, all right, I'm going to do 1 over R1 plus 1 over R2. So in your calculator, guys, this is what I want you to do. All right, we're going to go into it real quick and just practice it. It was 1 over 1 divided by 10 plus 1 divided by 40. So everyone's going to do that. 1 divided by 10 plus 1 divided by 40, just like that. All right. However many resistors there are, you would do that same pattern. Then you're going to hit equals. You're going to get a decimal. That's not your final answer. You do 1 divided by that answer. So then the answer, see where it says A and S all the way in the bottom left. That gives me my previous calculation's answer. So that 0.125. That one's not terrible, but like there's going to be some where you may have 1.11 repeating. And so you want to use that whole unrounded thing to get the best possible answers you can get. And then click it, and boom, it gives me a value of 8. So the total resistance for this circuit right here is 8. Well, Mr. Lombardo, how am I supposed to know that this is a parallel circuit? Well, good question. See how there's 1 path that it can take plus a second path that it can take. A series, all right, only has 1 path that it is allowed to take, which is what we kind of dealt with last week. All right, so like this dude over here, this is a series. Why? Because it only has 1 path that it can actually take. I wasn't talking to you. Watch. Okay, so does it work even if we have big old numbers? Yeah, it does. Okay, if we have things in the thousands, is it still going to work? And how would I find that? You do the same idea, like 1 divided by 1,000 plus, let's say 1 divided by 2,000 plus 1 divided by 4,000. Get a tiny ass number. That's not your final answer. You're going to do 1 divided by that answer. Okay, and then it may tell you to round to 1 or 2 decimals, okay, from there. But that is how you would go about it. Current, that is a little bit different. All right, it's actually very, very easy once you know what the voltage is, and I'll explain. So total voltage is, once you know what the battery is, all the resistors, all right, each branch has the same voltage is going to be equal throughout. So In series, current was the same at every single point. In parallel, the voltage is going to be the same going through each branch. All right, so really the voltage and current kind of flip-flop, and then the resistance, all right, yeah, it's a little funky, but we're going to do, all right, a few practices like that, and it becomes pretty easy. So another assignment that I posted for you guys, or another, it wasn't even an assignment, it was material, parallel circuit practice. So when you click on that, it has 3 links. And I'm going to tell you, you definitely want to go through these 3 links. Why? Because these are going to have some questions on your test. I pulled from here. I'm telling you now, a couple days in advance. They're going to be like, all right, dang, what is the voltage going through the 25 ohm resistor? My question to you is, well, what is the battery's voltage? What is the battery's voltage? Literally look up where the battery is and read me that number. 15. Yep. Hey, what is the voltage going through this 50 ohm resistor? Again, what's the battery? Okay, and that's it. To find the voltage going across any resistor, that's what you have to do. This one will be 40 again. Okay, now I'm not going to go through all of them because I think once I go through X amount, it kind of like will close me out and I still have to work through it with another class. But yeah, it's the same idea. It's the same concept, right? If in this one I said, hey, what's your jersey number? So if I said the battery here is 28 volts, the voltage going through the 10 ohm resistor would be 28. The voltage going through the 40 ohm resistor would be 28. And then from there, all right, we can solve for current or whatever else that we are looking for. All right. So the next thing is determining the current. And all right, so specifically here, they ask, what is the current for the 50 ohm resistor? Well, I'll tell you. All right, if you were to draw a triangle for Ohm's law, it's V is equal to I times R, correct? Correct. Now, if I wanted I, if I cover that up, what does that tell me? V divided by R. So just like we did with series, if I know what the voltage is, and the voltage is 40, and I want to know what the current is going through this resistor, it would be 40 divided by whatever resistor value. All right, so if I want to know what it was for this one, it would be 40 over 30. For the 50 ohm, it would be 40 over 50. And again, for 40 over 30. So into my calculator, 40 divided by 50. What do I get? 0.8. Let me go here. Slap. Correct. What is the current going through this one? Oh, it happens to be the same 2 numbers, but for example, if it was 40, if they asked for the 30 ohm resistor, it would be 40 divided by 30. And it should be like a 1.25. I don't even know. But whatever that comes out to be, that would be our guy there. Again, guys, that's pretty simple, yeah? Correct? Let's try one more then. Okay, well, what is the current going through this resistor? Again, this is parallel. Why? Because there's multiple branches. So they want to know the current through the 50 ohm resistor. 50 ohm resistor's here. The voltage is 60. So I'm looking at 1.2. Ba-bam. Okay, what is the current through the 20 ohm resistor? I would do 9 divided by 20. Okay, now determining the equivalent resistance and resistance versus specific dudes in parallel. Dang. What is the equivalent resistance? Or which is another way of saying what's the total resistance? So again, for that, our equation is down here. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So I want everyone, guys, to do this into their calculator right now. We have a 10 ohm, a 10 ohm, and a 10 ohm resistor. So what you're going to type into the calculator on your computer, you don't want to do it on your phones because it doesn't work out right. You're going to want to do 1 divided by 10 plus 1 divided by 10 plus 1 divided by 10. Right, so we had those were our 3 resistor values. Hit equals. You should get a decimal. That's not your final answer. You do 1 divided by that decimal. So 1 divided by my answer, and I get 3.3 repeating. So I'm going down and I'm looking for that guy, and I found it. Click try it. Booyah. Okay, well, what about this one? How many resistors do I have? 2. So someone tell me, all right, tell me what would I need to do to solve for this?
1 divided by 30 and 1 divided by 20.
1 divided by 30 plus, good, okay, 1 divided by 20, yep. You're going to get a decimal, tiny number, but that's not our final answer. You got to do 1 divided by that answer. And you get 12. Okay, you guys understand how to go about this? And then the only other, nope, we don't care about that one. Okay, so let's open up our parallel circuit walkabout. All right, so you guys need to go to this. This is your assignment for today. All right, you're going to open the Google form because this is going to count as a quiz grade. This one's going to count as a quiz grade.
The walk around, right?
Yep, parallel circuit walk around. You need to open the Google form and then open up the Google slide so you can see what you need. So you should basically have a couple things open. All right, the Google form, parallel circuit walk around slide, and definitely the calculator. Also, you're going to want, like I said before, a piece of paper, all right, for scrap paper to show your work. Because in the assignment, what does it say? This will count as a quiz grade. You will answer the questions from the Google Slides on the Google form. It's not going to let you submit until you have all the correct answers. All right, please show your work for those answers on a separate sheet of paper and then submit it as an attachment. Got it? So you open up your Google form. Here's going to be our slide. Now I'm going to go through one of them with you. Which one do we want to go through? Do we want to go through 1, 2, 3, or 4? This is 1. They only ask you 1 question. Number 2 asks you 1 question. Number 3 asks you 1, 2, 3, A, B, C. So, or 4. Which one would you like to go over? You're going to get 1. 3?
All
4?
3 questions, all right?
Huh?
All 3 questions are 3 or 4?
No, 4 since it has more questions.
All right, 4 because it has more. Got it.
Calm down.
Hey, you zip it. All right,
Yeah, so we're showing our work on this paper.
you're gonna show your work on a separate sheet of paper. All right, I have a piece of paper up there. You guys can grab. Want to get one for him too, and then
Who needs
if he needs,
paper?
if he has a pencil.
I'll change it for pencil.
Okay, so let me get this set up. All right, so just by looking at this, one question I want to know is, okay, how many resistors do I have? How many resistors do I have? Okay, I got 4. Dope. Now, so for this, guys, we have to find a couple different things. So we have 1, 2, 3, 4 resistors. It's in parallel, all right? Why? Because it's not just one rectangle. Okay, there's multiple little branches that this current can go through. Okay, one thing that they don't give us is the total voltage. They don't give us the battery. But what they do tell us down here is this, the total current. The total current is 20 amps. So they want us to, 1, find the total resistance. Okay, so I have my drawings. So here we go. We have 90 ohms, 60 ohms, 30 ohms, and 20 ohms. To find RT, right, to find that, it would be 1 over R1 plus 1 over R2 plus 1 over R3. That's an R, that was a B. Sheesh.
Yes.
And there's one more resistor. Miss Navarro, that looks scary. Well, relax. It's not terrible. All right, you're just writing a couple things down. And then we're going to do this, right? Underneath that, 1 over total resistance is equal to 1 divided by 90 plus 1 divided by 60 plus 1 divided by 30 plus 1 divided by 20. Okay, so once you guys have that, well, what do I need to do next? I need to figure out what the heck that decimal is going to be, correct? So like I said before, okay, when finding total resistance or equivalent resistance, they're the same thing. Add all the 1 divided by R's in your calculator, hit equals, you're going to get a decimal. Then do 1 divided by that answer to get your final. Okay, so once you get your decimal, you can do 1 divided by second answer. That's for a calculator, or if you're using the Google calculator, it's just 1 divided by answer. So let's do this. So everyone should be doing this. All right, in the calculator, it should be 1 divided by 90 plus 1 divided by 60 plus 1 divided by 30 plus 1 divided by 20. Okay, that gives me an answer, right, of 0.111 repeating. So this is how I write it out. 0.111 repeating. But that's not my final answer because I have to do 1 divided by that. So back into my calculation that I got, I would do 1 divided by the answer, and I get 9. So, I would say, hey, we got 9 ohms. That would be our answer for 4-1. So on the Google form, okay, 4-1, you just type in the number 9, and that should be good. You don't type in any units or anything like that. Yeah. Now, if you type 9, it should look normal. But let's say you type in 7. Go for it. It says, try again, right? It should.
It does when I go do like number 3. Oh, yeah, okay.
All right, so yeah, we want to make sure that this is our guy. So then, well, crap, now they wanted us in number 4-2, find the total voltage. Okay, so using Ohm's triangle, now that I have RT as 9, and I have IT, which they gave me, and that was 20. So to find that, VT is going to equal IT times RT. So we would do 20 times 9, and that gives us what? 180 volts, baby. So that would be your answer for 4-2, just 180, not 180 volts. Now I'm writing it up here just because that makes it easier for me, just like we looked at on the website, the Brain Genie thing, where we could kind of go around and play around with that. So now to find the current, because they want to know what the current is going through each individual resistor. Well, now it's simple, right? Looking at my triangle, if I wanted I, what am I doing? V divided by R. And just remember that, just like in series, all the numbers go together. The T's totals go together, current 1 and resistor 1 and voltage 1 go together. Okay, well, wait a minute. How do I know what voltage 1 is? I only know what the total is. Guess what? Parallel. Voltage is going to be the same all across each branch. So V1, 180. V2 is 180. V3 is 180. And V4. So I draw this out. This guy's going to be a 180. And what is the resistor value going through the first, or for the first one? 90. Okay, so I'm going to do 80 over 90, or 180 over 90. What does that equal? 2 amp. All right, now if I did,
That's for 4A.
that would be 4-3A, now 4-3B, I2. That would be V2 over R2. Which again, that would be 180 now, but this time it's divided by 60. And that should equal what? 3. To find this third current, or the current going through that third branch, 180 over 30, and I believe that's 6. And then the last John, that dude is going to be 180 over 20, which gives me 9 amps. So we have 2 amps going through the 1, 3 amps, 6 amps, 9 amps. Okay. So the current's not going to be, it's never always the same going through all the branches, unless they're all right, they all have the same resistance values. But really quickly, see this equation right here? In a parallel, the total current equals the current going through the first resistor plus the second plus the third. So just curiosity, what is 2 plus 3? 5. What is 5 plus 6? And what's 11 plus 9? So I have a total, right, of 20 amps. If I added these guys together, like the equation says, I get 20 amps. And what was our total current to begin with? 20 amps. So you see how that works. So guys, those are going to be when you write all this out.
Wait,
Yes, sir.
so the whole current of this box is 20 of that box up there?
Yeah, so they gave us that in the beginning. They gave us the drawing, not the 180, but they said the total current was 20 amps. So when we find I1 plus I2, or however many there are, we know that it's got to add up to equal that. So, oops, excuse me. That, guys, would be how you go about and solve for number 4. We can do one more.
Third.
I'll set you up for 3. No, come on. 3 is the only other one that promotes a challenge.
Alright, let's do 2.
2? All right. Okay, find the total resistance. All right. We have 1, 2, 3, 4 resistors. All right. Oh, that's cake. You tell me what I need to do then. The 1 divided by that whole sequence. All right. So you're going to tell me the numbers. All right.
1 divided by
1 divided by 1,000.
1,000. 1 divided by 2,000.
Plus
1 divided by 3,000. Wait, is that? No, that's another 2,000.
that's another 2,000.
And then 1 divided by 4,000.
Okay. I get a very, very tiny number, but that's not what, right? What else do I need to do? Good. 1 divided by that. And you're going to get an answer of 444.44 repeating. So you cut it off, and it says here, I say into it, round to 2 decimals. So when you type that in your Google form, all right, for number 2, if you type in 444.44, it should be good. Okay? So the only thing, guys, different here is instead of when we were given the current, we're given voltage to begin with. So find total resistance go to 1 decimal, and then do total voltage divided by total resistance to find total current. So let me add that right here. Okay, so we have I T is going to equal V T. Oh shit! Sorry. So guys, I hope that makes sense, right? So to find total current, you have your total voltage, which is 12 here. You find total resistance like we just did using those numbers here, 1,000, 2,000, 4,000. I said here, round to 1 decimal. Then boom, you'll get the total current. All right, and for total current, I would say use the first 2 decimals that are not 0. I'm sorry, no. Find total current, so it should be 1,000. Let's see, real quick. So guys, just to let you know, the current for 3-2 should be very small. It's going to be a decimal. Okay? It's going to be 0.0 and then two non-zero numbers for 3-2. So 3-1 should be in the hundreds for total resistance, but the total current should be pretty low. If that one's going to be a decimal. All right? So once you find this, you'll know this is like, let's just say this is like in the 100 somewhere. Total voltage is 12 divided by whatever you get for 3-1. It's going to give you your answer for 3-2.
So for the resistance for 3, I would do 1 divided by 1,000 plus 1 divided by 2,000 and then divided by 10.
No. Plus 1 divided by 4,000.
And that answers your resistance?
Well, close. That answer will give us, that answer is going to give you a decimal. If you did that, right, 1 divided by 1,000 plus 1 divided by 2,000 plus 1 divided by 4,000. You're going to get a tiny decimal. And then this is kind of what I tried to explain before, right? Your resistance value shouldn't be a decimal.
Okay.
like something less than 1. So when you do that, you're going to get a decimal, and then do 1 divided by that answer. 1 divided by that final answer. All right.
It gave me a decimal then though. You got it.
You may get a decimal along with it. So spit that. What'd your number get?
0.00175.
Okay, now you're going to do 1 divided by that answer. All right, so like if you did it up in the calculator, you said what was the number?
0.00175.
00175?
Yeah. 0.00175.
Oh, 3 zeros. Shit. Like that, right? Okay, so then you do 1 divided by that answer. No, it should only be 0.00. It should be this.
For 3,
It's 0.00. Yeah, that's how it is.
Okay. So then that should be what your resistance value is, and I say round to 1 decimal. So 571.4.
but 3 A, B, and C be decimal.
Yes.
Okay.
3A, B, and C are also going to be tiny. They're going to be very small numbers, decimal.
And I can just keep that for the same, right?
Hmm?
Like a rounding rule.